Good morning, guys. Today I'm going to talk about chapter 9, coordinate geometry. Alright, so today I'm going to dive a little bit deeper into this chapter, coordinate geometry, and this should be the last part of this chapter. So let's take a look at an example. Alright, so we have our x and y axis here, and they are both labeled. Alright, so remember to label your x and y axis, and these are the scales for the x axis, and these are the scales for the y axis. Alright, so let me plot 2 points. So let me choose this. This is my -2 and 0. So remember, this is your x coordinate, while this will be your y coordinate. Okay, by the way, you should know by now that I am just emphasizing this pair of values here. Okay, let me choose another point. Let me choose this. Okay, this is your 0 and 2. Alright, so with these 2 points you can actually link it up, and you should get a straight line. Alright, so let me make the straight line thicker. Alright, yeah, so this is the straight line. Alright, so what is the gradient of this straight line? Right, so if you are asked to find the gradient of this straight line, okay, by the way, the letter m is used to represent the gradient of this straight line. Alright, so to find the gradient of a straight line, what you need to do is use y1 minus y2 over x1 minus x2. Alright, so if I take this pair here as my x1 and y1, so this pair here will be my x2 and y2. Okay, so your y1 is 2, your y2 is 0, and your x1 is 0, and then your x2 is minus 2, and then you end up with 2 over 2, and that will give you 1. Alright, so the gradient of this straight line here is 1. Okay, so now let me continue to get another straight line. Alright, so let me draw a straight line here. What about, let me just take this. Okay, before I draw a straight line, so I need to plot 2 points first. Okay, let me start with this point, which is my 0, 0. Okay, over here at the origin. This is also called the origin, and let me pick 1 and 1. Alright, so with these 2 points, so let me label point 1 and 1. Alright, so let me link these 2 points up. Alright, so make it thicker. I'm going to use a different color here. Alright, okay, so let's figure out the gradient of this So let's figure out the gradient of this red straight line here. Okay, so similarly, you use the formula y1 minus y2 over x1 minus 2. Alright, so the y1 here is 1 and y2 is 0. x1 is 1 and then x2 is 0. So what you have? You have a gradient of 1. Okay, so in these two cases, okay, you have a gradient of 1. Can you see that? And so if you look at these two, straight lines, okay, they both have a gradient of 1. Alright, so I want you to observe these two lines together, and what can you observe? Right, so I hope you can actually see that. Let me label first. So this is my line 2. Alright, this is my line 1. Alright, so the relationship between line 1 and line 2 is line 1 is actually parallel to line 2. Alright, so this is the symbol for parallel 2. Alright, so what I'm trying to say here is, okay, so if this line 1 is parallel to your line 2, and in this case they are parallel, therefore they have the same gradient. You see, so let me call this my gradient m1, this is my gradient m2. Okay, just to differentiate the two. Okay, so you use line 1 to represent the blue line, so you use gradient 1 to represent your gradient of the line 1. Alright, so the conclusion here is, let me write the conclusion here on the left. The conclusion here is, if line 1 is parallel to line 2, okay, your m1, which is the gradient of line 1, should be equals to your m2. Okay, so m2 is the gradient of line 2. Right, so similarly, okay, the reverse is also true. Okay, the reverse is also true. What do I mean by that? So if m1 is equal to m2, alright, so your L1 is actually parallel to L2. Okay, so this is the conclusion from this example. Alright, so please take note of this relationship. Alright, and next, and let me continue. So I will use the same diagram. I'm going to delete most of this stuff. Okay, so we have explore. So while I'm cleaning up for more space, we have explored the relationship between two lines if their gradients are the same, right? So now let me continue to explore another type of relationship between two lines. Alright, so let me get rid of this. Okay, I don't need the red line, and let me label this. This is my -2 and 0 points. Alright, and this is my 0 and 2 point. Alright, so you have these 2 points, and this is your line 1. Okay, so just now we talked about two lines and they are parallel to each other. The gradients of these two lines are the same. Alright, now what about this? What about, okay, before that, I would like to plot 2 points first. Okay, so what about this? Let me plot this point, which is my -1 and 1, right? And this point 0 and 0. Alright, so with these two points, I'm talking about this point here, yeah. So let me link up these 2 points. Okay, so let's find out the gradient of this line 2 here. Okay, so let me make the line thicker so that you can see it clearly. Alright, so let's find out the gradient of so the gradient of line 1 is 1, right? Because we have found this just now. So now let's find out what is the gradient of line 2. Okay, so the gradient of line 2 is y1 minus y2 divided by x1 minus x2, and your y1 is 1 and this is 0, and you have your x1 which is -1, and then this, so 1 divided by -1 is -1. Alright, so with this, so I hope you can see the relationship between your m1 and your m2 is, so sorry, so your m1 times your m2 is actually equals to -1. Alright, so if you have your this m1 times m2 is equal to -1, what can you conclude here? You can conclude that your L1 is actually perpendicular to your L2. Alright, so that means if you look from this diagram, right, if you look from this diagram, so you can actually see that they are actually perpendicular to each other. Alright, okay, so the conclusion here is this. Okay, if m1 gradient 1 times gradient 2 is equal to -1, your this line 1 is perpendicular to line 2. Alright, so this is a symbol for perpendicular. Alright, perpendicular means 90 degree to each other. Alright, so that means the reverse is also true. The reverse is also true. So what do I mean by that? So I mean if L1 is perpendicular to your L2, alright, so your M1 gradient 1 times your gradient 2 is equal to -1. Alright, so this is the second example of the relationship between two gradients of two lines, and they are perpendicular to each other, and the multiplication of the gradients is -1. Alright, so with this I'm going to conclude here today, and thank you for watching my videos. If you really love my videos, please subscribe to my channel. Alright, so thank you, bye.